Okay, we're going to begin today lesson on interest, simple interest and compound interest, and this corresponds to some chapter 8 material for week 3. First problem we're going to look at is on page 458, problem number 9, and it's a simple interest problem. And I have here the formula for interest, simple interest. I equals PRT, interest equals principal times rate times time. And A stands for the amount that's in the account after a certain amount of time, which is that initial principal plus interest. And the formula then reduces to P times the quantity 1 plus RT. Now, on page 458, problem 9, we would like to compute the interest and the amount in the account when the principal is $3,000, the rate of interest is 7%, and the time is 2 years. Well, we're simply going to plug into our formula here to compute the interest, and then we'll add the principal plus the interest. Interest is equal to principal times rate times time. The principal is $3,000. The rate is 7%, but as a decimal that is 0.07. Time in years, 2 years. Now, we multiply these three numbers together, that comes out to $420. That is the amount of interest that's accrued. The amount in the account is simply the principal plus the interest, 3,000 plus 420, $3,420. The second problem on that same section is problem number 21. We want to find the principal, the amount that should be invested today to accrue a total of $6,000 at 8% over 2 years. Well, it's the same formula that's been algebraically manipulated. We simply take this quantity, 1 plus RT, and divide A by that, and that leaves the principal. So here's our formula. P is equal to A over 1 plus RT. Now if we substitute into this formula, we start with 6,000, that is the amount that we want to accrue, 1 plus the rate 8%, 0.08 times 2 years, and that's 6,000 divided by 1.16, and the principal that should be invested today is $5,172.42. Note in this problem, don't round off, take the next higher penny amount. Rounding off will make you a little short, so this is not rounding off. The next problem is on compound interest, and this is on page 466, problem number 7. We would like to find the amount in an account where the principal is $4,500, the rate is 4.5%, compounded monthly for 3 years. Now, the first thing you have to do is interpret what is meant by monthly compounding. That means 12 payments a year. So in our formula, N is 12. The amount in the account, I'm going to substitute into our formula here. P is $4,500. And we have 1 plus R is 4.5%, which is 0.45. N is 12, and we have an exponent that is 12 times 3, or 36 compoundings. Now let's simplify that a little bit. 4,500, dividing that out and adding it to 1, we get 1.00375, and that is to the 36th power. At this point, you really need to have a scientific calculator. You can raise that 1.00375 to the 36th power. I'm going to write an approximate value here, 1.14425. Now on your calculator, you don't need to actually round off. You can carry all the decimal places and then just multiply your result by the 4,500. Final result here, $5,149.16. Okay. Pages are sticking together a little bit here. Okay, there we go. One final problem in this section. We're going to compute the amount that needs to be invested, that is the principal P, to get $10,000 in an account where the rate is 6% compounded semi-annually for 3 years. So it's our same formula with the division done. Now, semi-annually means twice a year, so in that case, N is 2. Let's plug into our formula. P is 10,000 divided by 1 plus 6% is 0.06 divided by 2, and our exponent N is 2, and for 3 years 2 times 3. Simplifying a little bit, this becomes 10,000 over 1.03 to the 6th power. Now, you can do that all on your calculator. Final result here, $8,374.85. That is the amount that should be invested today to accumulate $10,000 in the 3-year period.